You're ready to dive into generative AI? Whether you're just starting out or looking to level up, this video is for you. Today we are laying down a roadmap to guide you through everything from building intuition around AI to mastering advanced concepts like agentic frameworks and RAG and evaluating agentic frameworks and agents and saying agents multiple times will make this video explode, right? Right? Well, there's a lot to cover, so let's jump right in. Gen AI has been a really hot topic. Oh wait, how can we start? The big question, how do we get started learning Gen AI? We all know that Gen AI is like super hip right now. I mean, there are reasons why we want to learn it, right? It could be because we want to get into this field. We're just fascinated by it. We just want to know that, okay, if we want to adopt it as a tool in our projects, how do we go about doing it? What I want to do in this stream is try to lay out a roadmap that we can follow, not just to learn Gen AI like from an absolute beginner standpoint, based on our personal journeys, where do we lie on this roadmap and what should the next step for us be? So it's not just like a getting started guide. It should also be like a exploratory guide where if I'm already into the space, we know how to move forward, where to move, how do we expand our horizon, and what's the mindset we can take to kind of do this ourselves, because this is constantly evolving. What we're going to discuss today is going to be irrelevant in 2 months. But let's try to get in a framework at least, some base items, which we know that it's going to help us and last us for time. Okay. So let's try to make this roadmap and we try to make it as a graph, okay? So let's do this. So we are making it for a person like me. So there you go. That is me. As cute as a button. That's me. First thing, I think this is like a precursor. So I'm gonna put it as like a 0. That's the first thing we need to start with. I think no stream on roadmaps could start with that. Actually, you know what? Don't do Python. We have a Golang mascot here. You're not allowed to do Python. You'll get banned. You'll get canceled if you do Python. Actually, you won't. Don't worry about it. What we need instead, we don't want Python. We don't want to talk about Python. We want to talk about the developer mindset. A developer mindset is basically a way in which you can design systems by breaking down bigger problems into smaller problems. Just learning Python is not going to be enough. You want to make sure that whenever you look at a particular task that you want your AI model to do, what is the best way to design a system around it so that you can do it in the most reproducible manner, you can do it in the most cost-effective manner, and you can do it in a way that works. The developer mindset is essentially identifying the right problem statement. Let's start there. So what you need to do first is identify the right problem. If I have to take an example here, whenever you're doing RAG and things like that, or maybe you want to summarize a big passage of text, right? But you're not getting the answers you want. Why is that? Is it because the parameter count of the model is crazy? Or is it because the context window is too large? I mean, it just doesn't work. Or maybe because that model is just not tuned enough in that domain enough that it can understand the domain and extract the important points by itself. So identifying the right problem statement, I know it sounds like a very stupid thing, but that is like the most important thing you can do in Gen AI. So once you've identified the right problem, that okay, the problem I'm facing is that my model, let's say you're trying to summarize a financial document, okay? Or you're building a chatbot which can compare how Tesla did the year 2024 compared to something like, I don't know, Nvidia. You want to compare these stocks. And for some reason, even if you use the best model, you're not able to identify what's going wrong. What could be the problem? The problem could be that the model is just not smart enough to understand financial terminology. It's just not good enough. Another problem could be that the financial documents are so huge that it doesn't know what to pay attention on. It doesn't know what information to prioritize. Or it could be that, okay, doing all of that, like understanding what the numbers are, comparing the numbers between two stocks and coming up with a conclusion of which did better. It's just too vague a problem statement or requires too much computation overhead that a model just cannot do it. That's the problem. Now, once you have identified the problem, now we need to figure out, can I break this problem statement down into smaller problem statements? So instead of comparing Nvidia stocks with Tesla stocks in one shot, can I break it down into saying, okay, first summarize Tesla, summarize Nvidia. Start by summarizing these financial statements. But what are we doing here? We're trying to take a bigger problem. We're trying to break it down into smaller problems. Problem decomposition. Now, these are contrived examples. We The ability to decompose a problem statement is really underlooked. People don't spend a lot of attention there. Most of the work we do in AI, all the things we are going to talk about later in the stream, it all comes from the fact that somebody saw a problem and then they tried to decompose it, and that's how RAG came about to be, and that's how these different concepts came about. We need to understand how to decompose those problems. And once we have a small individual problems, now we can finally go ahead and say solve individual ones and then stitch them together. That's your developer mindset, right? I think it's basically a 3-level process. Now, if you're fresh out of college or you've just been coding for a year or two, you need to keep in mind that there are 2 levels at which you can operate. One is at the task level, where we take one task and we try to figure out how to break this one task down into smaller tasks. That's what I've been talking about so far. But once you get into it enough that you build enough intuition and you build enough experience, you need to start doing the same thing on a system level, where we are looking at functional problems and try to break that down into more technical ones, right? But remember this, no matter what are you doing, whether you're doing RAG, whether you're working with prompt engineering, it doesn't matter what you're doing. If you do not identify the problem statement right, if you're not able to break it down into smaller problems, you're gonna get stuck, and no amount of research papers are gonna help you there. So we got that out of the way. Let's go to the next one. Building intuition. I know this is super annoying. Everybody's probably gonna leave this video right away at this point because we did not start talking about GenAI yet. But before we get into the coding part, there's one more thing we need to do. Once we have a developer mindset on where we are looking at problems and we are trying to get into the mindset of, okay, what's the problem? How to solve a problem, right? We're getting into this problem solving mindset. The next step is building intuition. The mistake I made when I started was I did not spend enough time building intuition. I know a lot of people say that LLMs are nothing but word predictors. They just predict one word or one token after the other. That's all they do. They're not intelligent. They just predict one token after the other. Pretty dumb things. They just keep doing the same thing. No imagination capability or whatever. To them, I say, sure, I don't care. Whenever I ask a model a question, it gives me an answer, right? If I ask it, what's the capital of Canada? It's gonna give me the capital of Canada. Don't ask me what's the capital of Canada. I don't know that yet. I'll figure that out eventually. But it gives me an answer, and that exhibits some behavior. There are some questions that it can answer. There are some questions it cannot answer. We need to figure out what kind of things can a model do. That is what I call intuition. What are we trying to do when we're working with intuition? Like I said, it's essentially what can LLMs really do. I know I do think of LLMs as human beings. I keep saying this. I think of them as my stupid kids who have no idea what to do. They can do some things really well. They're really good at some things, but they're really bad at the other thing. I have to stop using this kid analogy. This is just, my editor's gonna have a blast with this. These are the different dimensions in which you can build intuition. The first one is impact of keywords and phrases. Impact of keywords and phrases. I think this is the easiest one to get started with. For example, if I say, if a model is just not giving me the answer and but I wanted to give the answer, so I say that, you know what, if you don't give me the answer, my son would die. I don't have children. I don't have, you know what, my editor will die. That's a good one. That's a good one. Maybe threatening the model gives me the better answer. I'm sure you've heard of this before, right? You've heard of this example, and you've seen a lot of these weird cases where bribing the model makes it work. That's nothing but identifying the impact of those phrases, like saying things like, hey, I'll pay you if you do this, or if you don't do this, that will happen. Those are some extreme scenarios. But coming to a more practical approach, on accident, you're gonna figure out things like, saying, read this carefully. The word carefully, that usually starts giving better answers. Or saying things like step by step. That starts giving some better answers in some regards. The point is, you'll eventually figure out the vocab and the phrasing to use when you want certain set of answers. Again, I'm not saying it's going to work every single time. It's all use case specific. Everything is going to be very use case specific. So in fact, let me write that. I'm going to add that as a second one. Actually, all of this is use case specific. But yeah, that's the first one. Start building that intuition. Start building the intuition of keywords and phrases. Trust me. Like all my streams or whichever videos you've seen, if you've seen me do stuff and you're like, wow, AI could do that, that's crazy. Especially the agentic RAG one. It freaking blew my mind. Those were 32 billion parameter models. Those are cheap models. Like, it costs me less to run that model than pay my editor to edit these videos. It's a cheap mod. You can push that to production without worrying about breaking your bank. And the reason I could do that is because I intuitively know what works for what model. So I've understood that, okay, what keywords and phrases work in general, but I also understand that if I'm talking to Quen, deliberation, like giving it instructions which force it to do some thinking, some deliberation, is gonna give me better out. When I'm talking to Llama, making it talk a lot, like telling it to say that, oh, describe everything you want to do before giving me a JSON object, that will give me better structured responses. So instead of just saying, hey, give me a structured response, making it talk and making it describe what it wants to do before it gives me JSON, that's gonna be a much better way for Llama, just because it's such a chatty model, in general. But yeah, you need to understand this on a model level. So you'll have to play around with different models and try to figure this out, right? These are like the fundamentals. Once you figure that out, you'll start going a little bit deeper and you'll start getting into the territory of the different messages that are there. So a good tool to use for all of this, what I'm saying is, I think this is not free. You might have to pay a little, but I'm sure, you can do this with open source as well. But this is where I started, I just started using I never use OpenAI for my projects, but they have a good UI. I think there are some open source versions of this UI as well. Spoke about that in the self-hosting stream. There was Ubabanga. I hope I'm pronouncing that right. There was Open Web UI. I use Open Web UI a lot. So there are a lot of open source UIs you can use as well if you want it. Like over here, you can give it like a system message, right? So there's something called a system message. And then I can create some user messages. How are you doing? And it gives me an answer. Sure, whatever. It doesn't matter. Now I wanted to answer me in the voice of Pikachu. I love Pikachu. And I put in something like always answer in the voice of Pikachu, because why not? And this time I spell Pikachu right. Ha! I've done my homework. Pikachu learns. Did I not spell Pikachu right? I'm gonna take a Pokemon which I know how to spell. Now if I try this again, okay, cool. What if instead of doing that here, I do it here? Does it make a big difference? Now this is a very tiny thing, so it probably wouldn't make a lot of difference. Yeah, it's pretty much the same thing. It doesn't matter. But what I'm trying to hint at is as you start making your prompts and as soon as you start getting into like the prompt engineering domain, you need to start figuring out what's the role the system message plays, what's the role the user message plays, what keyword should I put in where. Now, these can only be explained as you get into the depths of it. So you'll have to start using this more and more. And like I said, a UI like this where you can put in different system messages and user messages and stuff like that, really helpful because you can try things out all the freaking time and you can even save these. So if you have like a problem statement at work or maybe you're learning something in your project and you're like, why is this rag not working? So just copy those prompts, paste it here and start tweaking things in this UI to figure out how to make it work. So the next step in building intuition is figuring out what to use in what message. Trust me, especially when we get into agents, this makes a big difference. Some models follow system messages a lot better. Some models prefer instructions to be in the user message. Like for example, let's say here I say answer in the voice Charmander. Oh shit. Now if I answer this, take a guess. What is it gonna do? What is the model gonna prioritize more? Is it gonna be the system message or is it gonna be the user message? What do you think? These are questions you shouldn't want to guess. You should know this intuitively. You should just know what's going to be prioritized. And like I said, it could be different for different models. Don't forget the above 2 points, right? The way you phrase these things matter. But yeah, let's just run it. And it gave a weird answer. What if I start saying always? So I'm introducing a new keyword now. So it says I can't do Pikachu, but I can do Charmander. So it preferred Charmander over. It made sure that it uses this because prioritizing the system prompt more, even if the user said something like that. Now, what if I want to discard whatever the user says? Ignore the voice the user mentions. And let's try this again. I'm going to let the previous one be. There you go. Charizard. I know, right? You thought it would use this user prompt. In fact, if this was Llama 3.1, I think Llama 3.1 would prefer the user message instead. Llama 3.1, in my experience, has been focusing a lot on the user messages rather than the system messages. I mean, it might take a lot of time to validate it, so I'm just going to skim through it. But the point is, this is what I call building intuition. You should know these things. What takes precedence, like we just saw, we also need to know how to phrase things in what. Like what phrasing should I use in the system message? What phrasing should I use in the user message? You need to know these things. Because remember, at the end of the day, they are indeed trained from a lot of training data. So the more closer you are to the training data, the better it's going to be. But luckily for us, since the training data has has become so huge at this point. There are a lot of options that we can play around with, right? We don't have to worry about this too much. But having intuition around these things is important. It's really, really important. So get a playground UI. Get a UI which does this system prompt, user prompts, and things like that. Get that in place. It really, really does help a lot. Trust me. All right, let's move forward. What else do I have? The combination of these is what prompt engineering really is. So all of these together, that's prompt engineering. So you just don't prompt engineer. Prompt engineering is not a set of patterns that you can just go like, oh, these are patterns which you just use. It's an actual logical exercise which you're doing off of your intuition. Like whenever you're not getting a result and you're using Quen and it's not paying attention to some important things, you'll start using words like carefully. So yes, that's essentially what prompt engineering is. Sure, there are a lot of people who figure out a lot of things for you. So you can use their prompt templates for sure. But the basis of prompt engineering comes from that intuition. So always remember this, build the intuition. Really important. Then we will move forward and we'll start getting into some deeper things. We'll start getting into things like what you see on the right side of the screen, which I have completely covered like an idiot. The right side of the screen, I have like response formats. I can add functions. What is this temperature thing? What does it actually do? People keep saying it's creativity, but what the hell does creativity mean for a model, dude? Does this have any effect? Max tokens? Is this just like a limit? Is it just a cap? Or does it influence performance as well? What the hell is top P? What does that do? What is presence penalty? What is frequency penalty? You need to start building intuition on these things. What we just discussed was the prompt engineering aspect, right? The second step of intuition is going to be the LLM settings. LLM settings, parameters, I don't know what to call it, but I'm talking about things like temperature, top P, and stuff like that. You know what I mean. Once you've got the instructions nailed down, like how do you actually give it the instructions or the inputs, you need to start getting into LLM settings. So see how it all plays together, right? And don't forget, all of this has to be model specific. You need to explore models, my friends. It's very important. Things that work for one model will not necessarily work for other models, especially when you get into the open source territory, right? So explore different models in terms of weights. So how does the same phrases or the same things we learned above influence for different parameter size models, like a 4O mini versus a 4O? How does that matter? Like the weights. What difference do weights bring in all of this? These are different dimensions across which you work. The second could be, now this is interesting, but based on, how the models are trained, proprietary versus open weight might give you different answers as well. I've not gone too much into this, but hey, maybe that's what you want to consider, especially if you want to say that, okay, I want to use GPT-4o, but I also want to use open source models and I want to like balance it out for cost purposes and things like that. Then you'll definitely need to understand what's the difference between different vendors and different open weight models, right? You'll have to do that. But one important thing I'm going to leave you with, it's inference time compute. What a lot of people have realized is just increasing the training data set or the parameter count is not giving a lot of benefits. So if you ever heard the news that are LLMs reaching a plateau, that's because the traditional, I say traditional, but the original mechanism of the transformers where you just shove in more data and more parameter count and hope it to work, that's reaching limits. So a new paradigm which people have started to explore is inference time compute, where instead of investing a lot of money during the training phase, we let the model run for longer. We'll let the model loop over itself, consume more and more tokens as input and output to come up with a better answer. O1 is precisely that. So when they say O1 thinks, it's essentially like looping over itself. Of course, I don't claim to understand it, but that's what we call as inference type compute, where instead of making it bigger, we're just giving it more time to figure it out. We're not changing the training data or the parameter count, we're just giving it more time. So it's an architectural change, focusing more on just giving the model more time to figure things out. And let's be honest. How many times has it happened with us, right? That sometimes we try to get a problem and we never get an answer. But we spend enough time with it, we still don't get an answer. That's precisely how O1 works. It will never give you the right answer. I'm kidding. It does work. I think O1, it's really good. I've never tried it out, but it seems to be really good. And it's just something to keep in mind. When do you even use an inference time compute based model? There are some open weights model on that as well. I think it's Quen with Quen is one one of the most popular ones in the open weight, like QWQ from Quen. I think that's a good one. But yeah, that's how you build intuition around instructions, around LLM settings, and around different models because they all work differently. Does that make sense? Are you guys with me? I know we haven't started in the depths of it, but trust me, the more time you spend here, everything else is just gonna come in naturally. Like for me, I started working with agents before I knew what agents were. I ended up making my own agent framework, and then AutoGen came along and I was like, hey, it's just doing what I wanted to do, but a little bit better. And I just landed naturally into it because, like I said, I made a mistake of not doing this. Then I went back and I spent a lot of time here, and a lot of things just started making sense. So that's intuition. Just remember when I said it's use case specifics. So I want to write this down. Try to figure out different kinds of use cases you can work with, right? So like summarization is one. You could even have classifications. You could have transformations. Transformation as in converting from one language to another, maybe going structured or, whatever. Things like that. What else do we have? I think that's all I've written. Yeah, that's fine. But you get the point, right? You need to make sure what instruction works for what use case, with what settings, with what models. That's a lot of things to balance around, but it's not a lot of permutation combinations. Once you get into the depths of things, you're just going to intuitively know that, okay, this is not going to happen with an 8 billion model. This is not going to happen with a high temperature setting. This is not going to happen by, just prompt engineering the hell out of it and making the best system prompt. It's just not going to work. We have to do something different. You need to know where to invest time in. Important pieces. I'm glad we got it out of the way. If you have a question on how do you build intuition, okay, how do I actually go about building intuition? Okay, you gave me a lot of these things, but I don't have enough projects that I could do to learn these things. That's a possibility. That happens. Hey, I don't judge you. But it could also be you're already in a project and, there are a lot of things going on in front of you and you just don't have the time to do it. How can you try to build this intuition while learning things and while doing things? How do you do that? I have some tips. So the goal is variety. You cannot do intuition by diving deep into one problem and just keep working on that one problem. You need to have variety. LLMs are not logical creatures. They are not deterministic, which means even if you figure out the exact phrases to make it work for one instruction, the moment you change the instruction even a little bit, it can go completely haywire. So the goal is not to strive towards perfection. The goal is to get variety. Like get as many different kinds of instructions as possible and try to get a generic idea. We don't want to overfit one solution to one problem because, like I said, it's indeterministic. It's not always going to give us the best answer if the instruction changes. We want a generic category. Generic intuition is better in case of LLMs because that means that you're never going to use prompt engineering techniques which is too specialized for just one use case. You'll always stay in the generic bracket, or at least you'll know that, okay, whatever I'm doing now is going to work for most use cases, and you'll know when to take the decision to fine tune for one particular use case or get deeper into the system prompt territory for one particular use case, right? So you want to be generic. You want variety. The way I do it, I spend a lot of time on a UI like this. There are a lot of open source UIs. So yeah, just get this UI and play around with it a lot. That's step one. Whenever you get a problem statement, always try to do it this way rather than, using agents and using RAG and using all that fancy tools. Be as raw as possible. Because remember, no matter how cool agents and all those things get, at the end of the day, they are just sending system prompts, user prompts, and assistant message. So get very familiar with these things. Second thing, start using ChatGPT, Anthropic, or whatever is your tool of choice for everything. So whenever you have a problem in life, like writing an email, figuring out a coding problem, I don't know, cheating on your test, whatever it is, try to default to using ChatGPT. Like how we just use Google. Like you just saw me. I just made a fool of myself in trying to spell Charmander. But my first instinct was just to Google it because my intuition tells me that Google will correct the spelling. And in fact, if it was a word, it would even define it. That's intuition I've built on Google. My first instinct was not to open a Pokemon game or Pokemon whatever encyclopedia. It was to go to Google. That's my default. But we need to start making ChatGPT our default. That instead of going to Google, we need to go to ChatGPT or whatever the tool it is. The way you use Google today, that's exactly how you want to start using tools like ChatGPT. Again, I keep saying ChatGPT. It doesn't need to be ChatGPT. It could be an open model which you self-host. It could be Anthropic. It could be anything. It really doesn't matter. But in your early days, it honestly doesn't matter. Use anything you want. I used to use Bing because Bing was the first thing which gave me free access to GPT-4. 4.0 had not come out back then. So I kept using Bing a lot. And to this day, I still use Edge because Bing was free only when you used Edge or something like that. that. Yeah, just start doing that, okay? The intuition part will be like in Google, we know that we just need to put the right keywords. In LLM, we'll have to figure out what kind of instructions and things like that to give it, right? That's the difference. But it needs to be like Google. Another thing what I'll also suggest is go to YouTube. There are a lot of stuff which happens on YouTube. Let's take an example. There are a lot of these guys who make these hacks and productivity tips. Go through it. Why? Because it's going to expand your horizon of what is possible with it. It's going to be useless. I think you'll just see 1 or 2 videos and you'll get the gist of it. But I think it's a good one. I don't have any recommendations because expand your horizon. Make sure you know how to use LLMs. You'll need to spend more time in these hacks if you've been using Google for a long period of time. How do you do your queries in Google versus ChatGPT? Or the mindset we come with to ChatGPT is fundamentally different than how you go to Google. It is a rewiring. It's a big rewiring. The more time you spend with Google in your software engineering career, the more time you'll have to spend watching these videos. Because these videos are a good way to rewire your brain by just looking at how different people are using it. And the third step is starting with the OpenAI SDK. A little biased here. I'm a little biased. I think OpenAI SDK is the best SDK to start with. So once you have intuition, right now you've not particularly been coding. You could have, but if you do get into coding, before you get into agents, you get into LangChain, you get into all of that crazy stuff. OpenAI SDK, if you don't know, is just this, all of this screen in Python or in any language of your choice. And that's the beauty of it. The OpenAI SDK is available in almost every language you can think of. And since it's just REST call, you can implement it yourself if you really wanted to. But I'm pretty sure no matter what language you want, TypeScript, Go, maybe even Python, I think they have an SDK for Python as well. I am not sure. I think they do. Not 100. Don't quote me on that one though. This is what the SDK is in essence, right? So the system message, user message, everything goes here. And it's playing with different things like models and you can even make like a complete chat history. Like what if I said this and then the agent gave me this and then I said this? What answer do I get? What if I change my system prompt? So I use a separate system prompt to generate the first message and then I use a separate system prompt to generate the next message. That's agents technically. But those are the things you need to play around with. Tool calling. Yeah, that's a good starting point. Tool calling. Absolutely. How do you make AI call functions? Do I need to change the system prompt to get better tool calling? Does that matter? The point is whatever we were doing on that playground, we are starting to do that using, this happens to be Python, but don't use Python. Python is a silly language. We're going to use Go. What else? Add an example for temperature and other LLM params. Okay, yep, it figured out everything. It's literally going to write the code for you. All you need to do is copy it and run it, man. And of course, if you're going to be running Python, first of all, but if you're going to be using Python, make sure you check out the video we have on YourTechBud. It's an amazing video. I mean, we had a lot of fun. We need to get comfortable with using the SDK and just messing around with the system prompt and these settings and things like that. So a couple of things I would try in addition to what we already did. So first of all, don't forget, whatever we did here still applies. But in addition to that, we are also going to be looking at first, tool calling. Start building intuition around that. Temperature, system prompt, user messages, all of that combination. Small weight models, huge weight models. What effect does it have on tool calling? When I say tool calling, it's function calling. It was called function calling earlier. Now they call it tool calling. That's the first thing. Second is go heavy with structured responses. You're going to be using structured responses a lot more than you think. That I can't tell you how important it is to have intuition around how to get the right JSON response. I'll give you some examples. YAML versus JSON. Everybody, when they think about structured responses, they default to JSON. Yeah, reply in JSON. But you know what? YAML is pretty good. If you want like a verbose answer, especially when you're saying describe something or generate a list of messages or generate a list of questions, YAML is a much better response format than JSON for those kind of things. So which format should you get the response in? These are the kind of questions you want to ask. Second is instructions. I know we've kind of already alluded to instructions up top, but instructions or rules. Sometimes you want to set up some rules, right? Like always follow this JSON schema. Those things are important. Where do you define that? In the user message, in the system message? How should I phrase it? How should I make sure that my model is not missing a rule? How many rules should I even put in? How many instructions should I put in? All those are important questions. Get good with structured responses. You're going to use it a lot. Indents are bad. That's why people hate Python, right? Oh no, that's not true, my friend. That's not true. I hate Python because it's Python. That's it. Everything about it, what's there not to hate? I am getting banned for that one. I am so getting banned for that one. The next thing I want to talk about is structured response as instruction versus response format. A lot of the people don't spend enough time on this. Actually, you know what? This is a sub point. What I mean by that is, I'm not sure if you guys have noticed, there is a way in which I can force OpenAI to always give me a JSON response. Like now, if I ask this the same question again, I'll strictly get JSON. No matter what I do, I'll always get JSON. That's what this guy does. If I say text and I try to run it again, you see, it's giving me some more things. It's not strict JSON. It could have some text here, it could have some text there, whatever. So the point is, there are ways in which you can force JSON as a response format, or you could say that, hey, you know what, answer in JSON in the instruction. It's important. Not all models support response format thingy, especially the open source one, but OpenAI does. And I'm sure a lot of people will start adding support for it if they don't already. Under the hood, it's just prompts. I mean, OpenAI, I'm sure it's just prompting the model in a slightly different way. It might be adding some extra instructions and things like that, probably. Maybe modifying the system prompt, adding its own system prompt. I don't know. It's still using a bunch of combination of the system prompt and the user prompt under the hood. But you get it as JSON. So you're not getting control over, making the AI talk a lot, or maybe using YAML instead of JSON or things like that. Do figure out what's the difference. Sometimes a strict JSON is more important than anything else, but you might have to play around with it. So I just want to point it out. It's important to know. And the last thing I want is get introduced to the topic of embeddings. This might be too soon. We had a complete video on RAG, which you can check out, which goes into what embeddings are, and we get into all of those crazy things. But when I say embeddings, I essentially want you to build intuition around how vector search works in general. What kind of vectors match together and things like that. Like I said, this is advanced stuff, optional. I think embeddings are important. At least start working with them a little bit. And I'm just going to put this down for reference because I thought this would be a good idea, but maybe this is not for you. You want to make your own vector store in memory. So basically, we have a lot of vector databases, right? ChromaDB, Pinecone, blah, blah, blah. Make your own. Make your own vector store in memory. Actually go ahead and implement cosine similarity or dot product or whatever. Go ahead and make your own embeddings. Store them in an array. Have a vector search algorithm. Don't implement indexes and things like that. Just basic similarity search, right? Semantic search, whatever you call that. Build that. That's important, right? The intuition we want to build here is how scoring works. Scoring, or you can even call it distances, I guess. That's what you want to really understand. When I have two vectors, how do you know what's similar? Is it based on the text? Is it based on some keywords? You need to get some intuition around it. This is very hard. Even I'm still trying to wrap my head around it. But the sooner you start, the better it's going to be. I don't think I have reached the level where I know whether a thing will match or not. I don't have that intuition yet. Maybe it's not possible. It's very model sensitive. Every model has a different thing. The scores for different pieces of text built out of different embedding models just works differently. Start getting introduced to it. Start getting introduced to the concept of semantic search. The goal is not to master the use of semantic search. The goal is to understand the limitations of semantic search. When you build this, when you try to build your own vector store and you implement all of these things by yourself, I want you to come out with the feeling that, oh my God, it's not the silver bullet. It doesn't answer everything. Gonna be really important when we reach RAG. It's not as simple as, just make embeddings and your job is done. It's way more complicated than that. And you really need to have some intuition around how embedding works to understand those limitations of vector search. Get started with those things. It's important, right? I have an exercise for you. When you reach this point where you're building intuition and you're writing OpenAI, while you're doing both these things, I have one exercise for you. I want you to be a complaint box. You see how I keep dissing on Python for all the valid reasons on the planet? I want you to start doing the same thing. Not for Python. I mean, you should do it for Python, but make a list of grievances. Make a list of grievances. Try to identify when using the OpenAI SDK. Let's take an example. When I started doing all of this and I started tool calling, imagine if you want to call a tool, you have to describe all the properties of that tool in JSON. This is JSON schema technically. You technically have to do all of these crazy things. If you have 10 functions, you'd have to describe all of this. So for example, this is calculate, right? If I was to write this calculate function in Python, it would look something like this. That's it. Something this simple needs so much text. I mean, yeah, technically we can even put a doc string here. I mean, you get the point, right? You get the point. This is really annoying. When I was doing function calling using the SDK, this was my number one grievance. Why is it so annoying to describe functions? In fact, you can even see the early code I've written in my repository where you literally see me handwriting all of this. You know what? I'm going to show you that example. This is how stupid I am. I've gone through the process where I can appreciate a lot of the decisions other people have. But if you look at my AutoGen example, which I've done it, hand roll all the functions manually. Number one grievance. What I want you to to do is start making a list of grievances when you're using the OpenAI SDK. Again, don't use LangChain yet. Please don't use LangChain yet. Try to make everything with the OpenAI SDK. And trust me, if you do all of these things, you don't need RAG, you don't need agents, you don't need any of that. Everything will be common sense. Literally. RAG, like I started doing RAG before I even know what RAG was. I started doing agents before even I knew what agents are. Arrive at those solutions because your developer mindset will eventually take you there. Your developer mindset will be like, okay, this is the best way to do it. And you'll eventually make those things. But while you're making those things, make sure you have a list of grievances. I've got some projects for you guys as well. If you want some projects, try to make it a generic chatbot. Try to take a generic topic and try to make a generic chatbot. Try to make a chatbot which can answer any question for Pokemon or any question for Dragon Ball Z, any kind of questions, right? Start with easy questions. Start making more and more difficult and only build it using the OpenAI SDK. You're not allowed to use anything else. You're only allowed to use the OpenAI SDK, Python, and maybe those scikit and those other libraries, right? But you're not allowed to use the so-called GenAI libraries like LangChain and things like that. Trust me. Do it that way. So try to build this chatbot, try to make it generic, try to throw all different kinds of questions at it. You're going to see a lot of problems. Like sometimes your answer is not coming right because let's say the model doesn't know anything. What if I literally take an HTML web page on Pikachu and give it to the model and does it give me a better answer then? Okay, great. It works. Now what if I want to ask questions on another Pokemon? Okay, so now I have to give two Pokemon's information at once. But eventually you reach a point where there are so many Pokemons, there's not enough information or not enough prompt space to give it. So now you need to figure out, okay, how do I break it down? Okay, so what if I do some kind of a search, keyword search, like I do some kind of a regular expression that, okay, if there's a page which contains Pikachu, then use it, otherwise don't use it. Whatever it is, start building it yourself. And we are not stupid. I'm not going to be ignorant enough that I'll say that you don't know what RAG is. I'm sure you've heard of it. I'm sure you've also used it. I'm sure you've heard of what agents are. I'm sure you've used it. Keep that in mind. Use those concepts which you see other people talk about. Use the concepts you might be learning through the other streams. Be aware of it. Don't be ignorant towards it, but try to implement using OpenAI SDK. So if you know about vector search already, which you do, I mentioned it like 100 times already. If you know that already, you know that, okay, vector search could be an answer to find the right information, whatever it is. Sure, implement it yourself. Make a list of grievances. I think a generic RAG chatbot is the best exercise you can do because it's an impossible target. It's impossible to make generic RAG systems at this point, but yeah, just start with it. How do you know that you can move on? How do you know that you can move beyond the OpenAI SDK now? When you get confident enough to a point that you're like, you know what, I can build anything I want with the OpenAI SDK and with, some other Python libraries, not LangChain, some other Python libraries like the math libraries, NumPy and things like that, right? The statistical ones. Once you get comfortable with OpenAI SDK, but are annoyed by it. So you know exactly what to do, but you're like, oh gosh, I have to use the OpenAI SDK. That's annoying. That's when you graduate and that's when you move on. The next step is to trust me, anecdotal experience, the people who subscribe to my channel, their models work a little bit better. It's just facts. It's just the way it works. But okay, the fourth one is GenAI Library. I am talking about, you know the ones I'm talking about. I'm talking about things like LangChain, Llama Index, blah, 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 blah. Now, how do you go about it? Because I've spent a lot of time thinking about it. I've also tried to talk to a lot of people. A lot of people even have asked me this question. There are so many freaking libraries out there. How do you explore or navigate this sea of libraries? Okay? That's where this list of grievances comes handy. It keeps you grounded. Try to find libraries to solve grievances. Try to use libraries to solve grievances. So I'm going to give you live examples on how I started using LangChain, okay? Now, one of the grievances I had was because I was playing with so many different models and every tool, now it's standardizing, but when I started, every provider had their own API. So their SDKs were different and they had a different way to talk. Their API was different. Everything was different. I wanted a way to standardize that. See what's happening here. This is technically not the right syntax, but it doesn't matter. Like when I saw LangChain, I was basically seeing how can I standardize making calls to different models. And what I saw in LangChain was, okay, I can make something called like a chat OpenAI thing, whatever. And then it's technically called chat.invoke. I can just do a chat.invoke and all I have to do is say system message and human message. Because I think Gemini did not support system messages for the longest time. And some people don't call it a user message, they call it something different. I mean, it's different. Everybody was doing their own thing. They did not have like an OpenAI compatible spec. Now most of them do. So now OpenAI SDK is all you need. But back then it wasn't true. So this gave me a standard way to talking to a model. So system message, always write it the same way. User message, it calls it human message, always write it the same way. Talking to the model, it was always chat.invoke. That's what it was. So a standard way of writing it. Does LangChain do more than this? Probably. I don't care. It's solving the grievance I had. I am grounded to the problems I have. This is how you want to start using libraries. Another different problem I had. Wait, this is pretty straightforward. Vectors. Embedding APIs are far more diverse than the LLM APIs. I think even today, not everybody supports OpenAI's embedding APIs. I think embedded APIs are also now everybody's using the OpenAI spec, a standard way to work with embedding models as well. With embedding models, there are some more problems like the number of string you can give together. So you're giving like one text at a time, right? But for performance, you might want to batch things up and give them multiple strings together. But every server has a limit that it can process only an array of 100 strings together, or maybe an array of 500 strings together. But when you did your RAG thing and you did your chunking, it produced 10,000 strings. So you want a way that you can auto batch it up and send only 500 at a time because that's what your server supports. This abstraction does it. Again, I had a grievance. My grievance was I have a big list of string which I want to embed, but I don't want to batch it up again and again because that's like code I need to write and it's annoying. LangChain has chunking or batching built into its API. Grievance with a solution. These are just two examples. There could be a lot more. Like again, for tool calling, LangChain has something called the add tool. You know what? I can show you this one. If we go to my repos, and here, if we go to LangGraph, by the way, my video on LangGraph is out, so please check it out. Like when you're working with LangChain, you don't need to like write those JSON objects. You can just do everything like this, like specify the description of the field next to the field itself. Again, you don't have to do it. If your fields are very self-evident, then you don't even have to do this. You can just write string directly, and you can just have your doc string or whatever this is called right in the function and just put add tool. And then what you can do in LangChain is that chat API model, which we had on this chat, what I can do is chat.bind tools. And the moment I do bind tools, it will automatically extract that JSON schema and all that crazy stuff for me. I love this. Literally, the three things I showed you about LangChain is what I use about LangChain today. There could be a lot more features. I honestly don't care. I have kept my exposure to LangChain grounded. Okay, it's grounded in real grievances. Because again, we are going as a developer mindset. We'll talk about exploration soon. I know a lot of you are itching like, but hey, I want to learn what other people are doing. We'll talk about that. But the best way to get started is to know what you're looking for. If you're window shopping, I mean, this is not window shopping. You need to know what you're looking for and then go inside that shop. Otherwise, you're going to be lost. It is true. What my friend told me that the level of abstraction in LangChain, the more I went into it, especially into its language syntax, it has like its own weird syntax. That's so stupid. Like I would never use that. But I don't know about it because I am only going to worry about the things I need. Exploration is separate, but identifying what you need is separate. So I have included LangChain in my toolbox. I use LangChain messages. I use LangChain tools. I love the way it does tools. I also use another feature of LangChain, which is text splitting. I use those things because those are things I had to do myself and I hated doing it myself. And I just want somebody to make it easier for me. So I just use that. But I don't use LangChain for my entire RAG just because it supports it. I'm just picking the things I care about. Developer mindset. You want to solve a problem and this is how you do it. But eventually you'll figure out that, okay, there are some tools you reach out to more than the others. LangChain being one of them. That's the point where you start exploring things. That's the point where you go like, okay, you know what? Let's take out this weekend and I'm going to go through all the how-to guides which are in here. One after the other. Does it mean you need to use them? Hell no. We only use things if it's solving a problem. We are a dev. Here we need to start thinking like developers. So look at all of this as an exercise to expand your horizon again. Okay, we are trying to expand our horizon here. We are trying to figure out what are other people doing which I can adopt. Maybe there's some things I did not build intuition on because I did not explore those use cases. Maybe other people have done it. Maybe there are some technical use case, not even GenAI related, just in terms of coding, which I did not foresee just because I've never done it enough. Maybe some other person has done it and that could be good. These are opinions which you're just going through and you're seeing for you whether it resonates with you or not. This is essentially how I would look at libraries. I can boil it down into just 2 points. First one is find the tools to fix your grievances. they should resonate with you. Because this is a young field, we don't have mature libraries yet. Everybody has their own opinion, which is fair. Opinions are good. Everybody should have their opinion. You should be able to criticize other people's opinions. People should be able to criticize your opinions. Opinions are good, but you need to find libraries which resonate with your opinion. So you need to form an opinion. And the only way you'll be able to form an opinion is if you felt those pain and you've tried to solve those pains you felt in some way. Like you'll be able to judge opinions in a more rational and a more fair and a more just way. So form the opinions and make sure that you find tools which resonate with your opinion. Once you do that, explore the guides of the tools which resonate with you. I wouldn't say explore everything, okay? Like a good thing you could do is like when Pydantic came out. I think small agents came out now as well, so we'll do a stream on that too. Whenever something new comes out, come to a stream like mine. Check out a video like what James Brigg does. I love that guy. Maybe Matthew Bowman. There are a lot of good YouTubers out there. See what they have to say about it. If it pikes your interest, go deep. If you think it's nothing compared to what you want to do, or it's not resonating with you at all, skip it. Doesn't matter. Or just if something is too popular and you're like, oh, I want to know what the fuss is about. Sure, check it out. But whenever you're checking something out, make sure you have a solid list of grievances in your head and you have some opinions on how to solve those problems. If you come up with a problem statement which a tool solves, like structured responses, Pydantic does structured responses really well. But you've never played with structured responses enough. Don't judge Pydantic. Try to understand the opinion the other guy is coming from. Why did they add those features in? What are they talking about? What is the problem they're trying to solve? Who is it for? Have I faced those scenarios? Is it corresponding to my grievances? Maybe it is, maybe it isn't. If it isn't, maybe you need to explore your horizon or maybe just reject it. If it is, structured response has been a problem for you as well, or it's annoying for you as well. How do they solve it? Does that match my opinion? If not, wait, what did they do? Why did they do it that way? And try to put yourself in the other person's shoes. That's the only way you can truly judge something good or not. And the answer's never gonna be like, what does your tech bud use? It's always gonna be what resonates with me. Trust me, like my friends who have been bouncing ideas out of, I respect them a lot. And whatever opinion they share with me, I know even if I disagree with them, I'm going to study the hell out of them. Because they have an opinion or they have a mindset they're approaching it from, and I want to know what their opinion is. Because it's an opportunity for me to expand my horizon or, conclude that, okay, that's not what I want to do. The way you solve it is your opinion. You might not have known a better way, which is fine. But you've already started crafting your opinion by means of doing it. Another way to form an opinion, which Prashant just mentioned, and we should definitely highlight that in the YouTube video as well. Sometimes keeping your opinion aside and just trying it out their way might help as well. Sometimes just reading about it is not enough. You might want to actually use it and see, okay, why are they doing it this way? Does it help? For what use case would it help? You know what? It doesn't help at all. I'm not going to use it. Whatever it is, it's fine. Try it out. So the point is, make sure you enter and or leave with an opinion. It's a game of opinions, my friend. And it's going to be this way till it matures. And tech takes time to mature. It's going to change a lot. Things are going to disrupt each other. Every day we're going to see a new library which claims to use a particular research paper, and that research paper claims to do a particular thing better. Sure. And it's not a marriage. Oh, I think I should write this down. This isn't a marriage. This isn't marriage, guys. It's not that if I use LangChain, I'll have to use LangChain everywhere. I can use LangChain in some parts. I can use something else in other parts. That's fine. As long as you know the technical depth you're getting into and you understand the consequences of using a lot of libraries. Just because you're using Pydantic doesn't mean you have to keep using Pydantic AI. This is speed dating. Maybe that's why I'm single. Okay. Realizations. Different parts of your applications would have different grievances. Even if you're doing tool calls in two different places, there could be different problems you're trying to solve. Like maybe in one place, there are too many tools to choose from. Maybe in another place, the data that needs to be put inside the parameter is too complex and the model doesn't get that right. You could use two different tools for that. For example, if the parameters are hard, I gravitate towards Pydantic AI. Whenever it's a data problem and a structure problem, I just tend towards Pydantic AI. If it's more like I want control in how the prompts are made and things like that, you can use something like L or LangChain. So I'm going to list down some libraries here. I don't want to talk about agents yet, but some good ones to start with would be LangChain. Maybe Llama Index if you're really building that chatbot, which we spoke about. Definitely check out L. I think L should be the first one you check out. I think L can dethrone LangChain for what I do at least. Not everything. Like I said, LangChain does have some utilities which are really good, like that embedding model thingy where it batches automatically. Some things in LangChain are really good. I'm going to give them that. Now, I know a lot of people have advised me to not say this. So I'm not going to say DISP, but I'm going to put in guidance. some library which has recipes on prompting. Again, LangChain already has that. Llama Index kind of already has that for some use cases. But I want you to start looking at different libraries which have opinions on how you should prompt, just so that you can, build more intuition on how user instructions and things like that should work. Doesn't matter. This list, maybe it works today, maybe tomorrow there'll be a better list. It doesn't matter. I'm telling you, it doesn't matter. You'll keep changing them and it's going to happen a lot. You get the point, right? The point is to go in with an opinion, or at least with a problem statement. Understand the problem statement you are solving versus what they are solving. That's where the developer mindset kicks in. Once you have a true appreciation for the problem statement, only then can you evaluate. Otherwise, you're shooting dots in the air. So you don't want to do that. In the exploration phase of your GenAI libraries, you're gonna reach a point. You definitely will see some features in a library which you did not even think exists. So whenever you come across a new feature, don't judge it. Instead, try to expand your horizon on, wait, oh, that's a new problem they're trying to solve, which I did not see earlier. Or a new way to solve an existing problem, which I did not think of earlier. Every new feature is like an opportunity to expand your horizon. That's how you explore life. In general, not just for GenAI. In general, that's how I do. And that's how I'd suggest you do it as well. And always criticize, even with human relationships. Always criticize actions and not the person, unless it's Python. If it's Python, you can just criticize it without any reason. Try to criticize features and not the library. Just because one library does one thing in a very weird way which you don't agree with, doesn't mean that their way would be invalid for a slightly different. Like I said, tool calling itself, depending on what you're doing and how you're doing, different libraries could give you better results. Do you want more control over the prompt, or do you want more control over how the data is and whether the data is in the right shape or not? Don't criticize the entire library, just criticize the feature coupled with the use case, right? Or for what use case are you criticizing that feature? Just remember that. Yeah. How do you criticize or reject? You can only do that once you understand the use case. Then understand the problem. How is this feature going to help? That's how you do it. I just feel that this community, like the GenAI community, it's become like Rust in a little way. It's getting a little toxic. In some places, be careful about it. I'm not saying that everybody is. I know like everybody on our Discord, they're just an absolute delight. I love everybody on my Discord. They're so good. They're amazing. I love them. Trust me, the roadmap doesn't matter as much as taking action. A lot of the times the problem we face is not that we don't have information or we don't have the knowledge. YouTube is great. A lot of people have published a lot of good resources for us. That's not the problem. The problem is not that we don't know where to we study from. The problem is to take action. And often working as a community, working as a group, knowing that there's somebody with me to help me through this, it really helps. And that's why on my Discord, we are going to start a weekly action call. I've put the link to the Discord again. The next one you want to get into, again, you can do it in parallel. There's no opinion on which order you take them in. Yeah, go with agents. When I was talking about the libraries, of course, you're going to come across agentic libraries. First, try to stay low level as much as possible. Don't go to agents before you've covered the low level stuff. Play with L, play with LangChain, play with Llama Index before you get into agents. Like not the agentic part of those libraries, like just the utility functions kind of those things, right? Agents are a well-defined, non-deterministic abstraction for reasoning, planning, and taking action. So whenever your use case falls into these categories that you need to reason out, you need to plan ahead, or you need to start taking actions like tool calling, that's when you start getting into like agent territory. Think of it like if you come from the programming world, it's like objects to encapsulate LLM. While talking to LLMs, we can't just keep prompting all the time, right? We can't use LangChain all the time. We want some fixed contract to talk to it. Like this is how you use it and this is how it's going to give me the answer. And it needs to be a way in which we don't have to worry about the system prompt. Like all the concerns of prompting, LLM settings, all of that should be abstracted away. It should be a simple function call for me. That's what an agent is. It's an abstraction which eliminates the need for me to think in terms of system prompts, user instructions and things like that. Of course, the person creating the agent would still have to think of those things, but the person using the agent doesn't have to think about those things. So agents is a way, it's like it draws a line between everything on top, what we saw here, and the usage side. So it makes using GenAI a lot easier for these kind of use cases. The next one you should definitely know is an agentic system. I think people don't understand, sometimes mess up with the difference between the two. An agentic system is something, it's a system which uses agents. So you're not doing like individual prompts anymore. You're technically using agents as that abstraction, so you don't have to worry about prompts. So when making an agentic system, you're not technically worrying about system prompts and things like that because you're using agents. So agentic system is a system which uses agents to influence the flow of execution. You have a workflow, you want to do some steps. What happens in those steps or how the flow of execution will happen, the if-else's, it's all happening basis on the response you get from agents. So it's all non-deterministic. So while thinking of agentic system, you don't want to think about prompts and things like that. You need to make that separation somewhere. Agents is that mechanism to create that subscription. It's just a development construct. It's not a physical thing. Agents are not inherently better. They're just using the OpenAI SDK under the hood. There's nothing fancy going on there. It's just using OpenAI SDK under the hood. The user of agents doesn't have to use those prompts. They don't have to worry about the system prompt. That's the important part. So if you're using agents and you want that flexibility wherein you stop thinking in terms of system prompts because it's so annoying, you're getting into agents. So yes, if you've started creating functions which automatically, create the system prompt and things like that, so that you just have to use functions and not worry about those system prompts within it, you technically have started making your own agentic framework of sorts. It's an abstraction. So you stop thinking in terms of the low level details. You're getting into some abstractions here. Good frameworks. I think every framework is a good framework. I don't have opinions yet, but I'm going to put these names in. Pydantic, amazing for structured responses. LangGraph, amazing for orchestrations, especially when you have like complex workflows. Actually, those are the only two which I have used. Take inspiration from these libraries. Study every agentic framework, make decisions. If one library fits you perfectly right, just use it. Just keep using it. Perfect. If you're like, oh, I like this of that, I like that of, I like the orchestration of LangGraph, but I like the structured responses of Pydantic. Sure, use them together. You can literally use Pydantic within LangGraph. Yes, you can do that. So play around with it. Mess around with it. Try different things. And again, form the opinion. Use your developer mindset. It's going to come in handy. Okay, when you're evaluating frameworks, I think you should use the same mechanism we discussed here. Try to understand what problem that framework was designed to solve. Like Pydantic is very production oriented, very type safe oriented, trying to get deterministic abstractions from indeterminate. I mean, it's still indeterministic. The way you interact with a Pydantic agent gives you a lot of security. It's not what I would use for every agent. It's just good for one use case. If I think I can implement that myself within a day or two and it's going to be good enough, cool, implement it yourself. Who cares? But if you think it's going to take you a lot of weeks to implement it and stay up to date and things like that, don't implement it. Just use it as a library. The point is, you'll have to figure out what's the use case, what's the problem, how are they doing it, how would have you done it, and if it aligns perfectly well, just use it as a dependency. Take the good pieces and build your own stuff with it. Now comes RAG. You probably already know RAG. Like I said, with agents, you probably will start implementing RAG before you start using a framework around it. You already know RAG, but there are a couple of pointers which I'll just throw in, which again, I think I've mentioned in my video on RAG. I have a video on it. Check it on my YouTube. A lot of stuff we're talking about, we have videos on it already. We have been busy, man. Start thinking in terms of pipelines. The moment you get into RAG seriously, you have to forget GenAI and you need to put on the data engineering cap. You are a developer. You need to start thinking in terms of data engineering. And there's a lot of tools and ecosystem built around data engineering. There's Apache Airflow. There's a lot of cool things. So start thinking in terms of pipelines. Off-the-shelf stuff like Llama Index to build your entire thing, not a good idea. Like use Llama Index, but not as a framework, as a library, and try to plug it in bigger frameworks, more mature frameworks like Airflow. So start thinking in terms of pipeline. There are two types of pipeline you just need to worry about. One is ingestion and one is retrieval. Ingestion is how do you store data in your knowledge database. Retrieval is how you get data to form the context. So start thinking in terms of pipelines. Get on the data engineering cap. That's important. And then because it's data engineering, you'll have to learn some more concepts. Again, if you want to do RAG seriously, I think you'll have to learn them. I don't think this is an option, but you'll have to learn data engineering, man. What things in data engineering? Like what's an ETL pipeline, ETL or an ELT pipeline? Well, like what's the differences? What is streaming? Stream processing rather. The different tools which are there. Like I said, Airflow. I keep coming to Airflow because that's what I was using because my team at work was using that. But there's Daxter. I mean, there's a lot of tools. The tools don't matter. Your anime chatbot is going to be your best friend. The point is have a generic use case. Have a generic use case where you can try different types of questions and then try to find ways to solve or get the right answer. One question could be, how do you get Pikachu's electric type attacks? That's easy. Another question could be, which Pokemons learn the move Growl? Another question could be, who has a better electric type attack between Pikachu, Raichu, and Pichu? Each question has a different way to get the answer. In fact, we have two videos on this. We have the RAG video and we have the agentic RAG video. The point I'm trying to make is the more questions you try to throw at this generic chatbot, the more problems you'll encounter like, oh my God, how do I do this? How do I do that? That's where a lot of the papers people have published is going to come in handy. RAG is one of the places where I actually care about the papers being written. It's hard to build intuition around RAG when you don't know how to do it, especially if you're not coming from the data world, right? I don't come from the data world. It's hard for me. Reading papers and reading the guides which LangChain and Llama Index have built on RAG really helps saying that, oh, you could do it like that. Ah, you could do it like that. Do it like that. So you want to expand your horizon as much as possible to a point where you know enough strategies that you know that, okay, for this use case, I need to chunk it this way, or I need to retrieve it this way. Like, you know, like for what use case, what kind of an ingestion or a retrieval pipeline would be important. That's where you want to get with RAG, guys. There are a few more things, which again, just keep it on your horizon. These are things I'm still learning myself. So one is evaluations. I don't think we'll be able to appreciate this till we take something to production. It's hard to reach there, but evaluation is one definitely we'll have to start looking into, which is essentially how do you make sure that my model agents keep working even if the model changes, or even if we give it a different kind of question. How do we know that a RAG pipeline keeps working even if the data increases in volume, or the types of question change, or whatever it is? Evaluation. It's essentially testing, like unit or integration testing, but for LLMs. And the last one is AI ethics, guardrails, I guess. How you can, make sure that PII information is handled properly. How do you make sure we are abiding by the policies and regulations set by the industry or by the company? All those corporate-y nuances, which is very important. Honestly, we probably don't care about when we're learning things. But these are things to keep in mind. But I think that sums up our roadmap. You start with the developer mindset. Start building some intuition around how prompting works in general. You get really good with the OpenAI SDK. I think OpenAI is a good standard to start with because everybody uses the OpenAI spec now. You get really good with it to the point where you're confident enough that everything can be built with an OpenAI SDK. It could be annoying, but it can be done. Then you subscribe to my YouTube channel, because why not? Now, since you have a lot of experience building the OpenAI SDK, you know where it makes you do a lot of work. That's when you start looking at libraries and go like, okay, how can I do this a little bit better? And you'll find some good libraries as you come around. You'll definitely find some good libraries. Explore it, see what they're doing, appreciate their opinion, criticize their opinion, diss on Python, make some ridiculous posts on LinkedIn. Sure, do all of those things. You might want to join my Discord after that, because I said we need to take action together. And these are some tangents you can take from there. Mind it, at this point, you can make production-ready apps. By the time you reach the GenAI library phase and you're good with what library to use for what use case, you should be able to make good apps. And trust me, when this GenAI wave hit, a lot of people were doing it just using this. But now you have a lot more options, so these are some tangents you can go into. But that's pretty much it. I will see you in the next one. Thanks for being here. Like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech bud here on YouTube, and hopefully in real life. Toodles. I don't know why I did that.